Assume during the lab report you have already known the spring constant of the rubber bands and the length of it, and also the weight of the egg and the length of the string which is the only variable you need to determine during the lab. So this is what your stuff will look like. So this is the height of the ceiling. This is the ceiling and this is the floor. And the height of the hook. And also the height of the string and the length of the rubber band and the X, which we can see from all of these. And if we want to determine when how long the string is, the length of string which can make the egg as close to the floor as possible, we should use this formula, the kinetic energy formula. Delta EKE is the energy, the kinetic energy. So it will be 0 because the first it's 0, and after, because it doesn't move at the ceiling at the highest point, and it's also still when it touches the ground. So it's mgh minus rubber band. So this is the mgh, and this is the rubber band has the force the rubber band has done. Why is this 1/2? It's because the F, as we can see, at each x the force is kx. So as we can see, this is the work the force has done. It only occupies half of this rectangular, which is half fx. So when it is fastest, we can solve the s from this, because we know the f is equal kx. So this is kx squared over half. Yeah, so we can solve this problem with simple calculation. And we can know the x. When it's fastest, we think that x prime is the length extended. So when it's fastest, the the accelerator equals 0. Why is that? As we can see on this page, when it's fastest, the a is still at this point, which is 0. And because we know that a first keeps still and then it gets bigger in the negative, in the downward direction. So when a is 0, it's the last point is not negative. So v is still increasing before ax gets 0, and when a gets 0, then a gets minus negative, the v is decreasing. So when a is 0, it's the fastest point. So when a is 0, the force exerted on the egg is 0. So there are two forces on the egg. The first is the mg, the gravity, and the other is the force of the rubber band, which is kx prime. So we can tell that when x prime equals mg, it's at the fastest point. So how fast is the fastest point? So we know how far it is. It's x prime. We can see that x prime. So h minus x plus x prime, which means, as we can see, h minus x is all this part and minus and it plus x prime. It's where it achieves the lowest point. So how fast is that? And is if we use the same formula again, Ek equals minus W, the kinetic energy of it and the work the gravity has done. This is how far it has fallen, and this is the force that rubber bands does. So we can solve this problem with calculation. So that's about it. If you want an overview of the sketch work again, yeah, that's it.